Have you ever wondered what is a wave? Have you ever seen waves or ripples in water? Or have you ever thrown a stone in still water and observed the circular pattern going away from the center where the stone was dropped? If you throw a stone, what do you see there? A disturbance. A disturbance that traveling through a medium or vacuum from one place to another place by transferring the energy is called a wave. When a wave is traveling through a medium, it will experience some local oscillations, but the particles in the medium do not travel with the wave. Or, in physics, a wave is a disturbance that transfers energy through matter or space with little or no associated mass transport. Wave consists of some oscillations or vibrations of a physical medium or a field around relatively fixed points in fixed locations. From the perspective of mathematics, waves, as a function of time and space, are a class of signals. So there are some words and some properties associated with a wave. The very first property is its frequency. Why there are different kinds of sound? A frequency is the number of wave cycles that pass through a given point in 1 second. Number of cycles per second. The next is its wavelength. Here you can see the distance between two identical points in a wave is wavelength. Generally we say that wavelength is the distance between two successive crests or two successive troughs. Different wavelengths of a wave or different frequency of a wave give its characteristics. If I talk about sound waves or if I talk about light waves, you can easily understand it. The red light has a longer wavelength, while ultraviolet and blue have very small wavelengths. There is one more term, amplitude. What do you mean by amplitude? The maximum displacement from the mean position of a wave is called its amplitude. Suppose there are two waves, one is of low amplitude and another is of large amplitude. So, the one which has more amplitude will have more energy, will do a large work done. If I talk about sound waves, if there are two waves, one of less amplitude and another of large amplitude, the wave of larger amplitude can go and can reach to a longer distance. And you can see there is a device called amplifier. When there is very less amount of sound energy coming out of the mobile through its speakers, if you want to do any kind of dance, you must need that device called amplifier to connect and to make that sound of large amplitude, and we generally call it the increase the volume, so we can enjoy the music with its large sounds. There is one more term called time period. The time taken by one complete wave to pass a given point in 1 second is called the time period. And here, time period is the inverse of frequency. If you see the frequency in hertz, if there is a wave completing one cycle in 1 second, you can see it here. This is a wave completing one cycle in 1 second. It means its frequency is 1 hertz. On the other hand, this wave completing 2 cycles in a second, so its frequency is 2 hertz. So the first wave is taking time of 1 second, while the other wave is taking the time of 2 seconds or 0.5 seconds, because there are 2 cycles in 1 second. In this way, the time period t is reciprocal of frequency. A frequency is the reciprocal of time period. And one more very important point is the speed of a wave. The distance traveled by a periodic motion per unit time is called speed of a wave. The speed of a wave is generally given by the equation f times lambda, where f is the frequency and lambda is the wavelength. Now let's go a little beyond in the types of waves. There are 3 types of waves based on direction of movement of particles of the medium. They are longitudinal waves, transverse waves, and surface waves. First, let's discuss about longitudinal waves. A wave in which the particle in the medium move in the same direction and opposite direction to the direction of wave propagation is called the longitudinal wave. Propagation is nothing but the direction in which the energy travels in a wave. Longitudinal waves are also called compressive waves. Longitudinal waves has compressions and rarefactions regions. Compression is a region in which the particles are very close together, and rarefaction is a region in which particles are spread out. However, instead of crests and thrusts, longitudinal waves have compressions and rarefactions. If you want to understand longitudinal wave, see if wave is going in the x direction, so the particles of the medium are moving in the x direction too, but they are moving in parallel direction, and they are moving back and forth or to and fro along with the direction of the propagation or parallel to x-axis. A compression is a region in a longitudinal wave where the particles are closest together. A rarefaction is a region in a longitudinal wave where the particles are furthest apart. There is one more type of wave called a transverse wave. If you have noticed, when you throw a stone in a still water, and suppose there is a thermocol lying on the water, but the movement of that thermocol is just up and down, it means all the particles of water and of that medium are going up and down, while the wave is going outward radially. So in transverse wave, the particles of the medium go perpendicular to the direction of propagation of the wave. And there is one more called surface wave. Surface wave is a wave in which particle direction is in circular motion. The example of surface wave is water waves and involve both longitudinal and transverse wave movements. There's one more type or characteristic by which we can differentiate types of waves based on ability to transmit. There are 2 types of waves based on ability to transmit energy through vacuum. They are electromagnetic waves, and others which need a medium are mechanical waves. Electromagnetic wave. If you have seen my video on light, you know that light is an electromagnetic wave and it is capable of transmitting its energy through vacuum. So even where there is no particle, these electromagnetic waves can travel and propagate. Electromagnetic waves generated by the vibrations of charged particles or only accelerated or oscillatory charged particles can produce electromagnetic waves. Electromagnetic waves composed of electric and magnetic fields which are mutually perpendicular to each other, and both electric and magnetic fields are perpendicular to the direction of wave propagation. An electromagnetic wave transmits its energy through a vacuum at a speed of 3 into 10 to the power 8 meters per second, which is very large. And there is one more wave called mechanical wave. A mechanical wave is a wave that is not capable of transporting or transmitting its energy through a vacuum. Mechanical waves require a medium to transport their energy from one place to another. Sound wave is a type of, or is an example of mechanical wave. Sound waves are unable to travel through vacuum because they would need particles. Water waves. So when there is no water, you would never see a water wave. Common example. Stadium waves are other examples of mechanical waves. Each requires some medium to travel. If you want some more videos like this, please share, like, and write in the comment section below. Have a great day. Thank you very much.